Welcome to Week 5, where we will continue to explore ways in which the criteria of justification can lead us to believe things that aren't true. I always wanted to be a magician. I always believed that I would have looked great in a stovepipe hat and a black cape. But alas, I stink at it. Watching me try to do magic is like watching a monkey try to read Shakespeare. It's so bad it's not even all that funny. So I've asked my good buddy, Dr. Bennett, to show us some sweet coin tricks. Check them out. Part of what I find fascinating about coin tricks are the ways in which they play with our senses of knowing. One of the things magic does is confront us with the apparent truths that we can't believe because they seem to violate other truths. We saw last week that perception isn't always useful. We can make assumptions that lead us away from justified true belief. This week, we'll continue to consider some of the ways in which our brains let us down. In the case of magic, it can be fun. At other times, not so much. One of the most important researchers of these phenomena is Dr. Daniel Kahneman, Professor Emeritus at Princeton's Department of Psychology. Kahneman received the Nobel Prize in Economics in 2002 for his work on prospect theory, which describes the ways in which people choose to think about probabilities and risk. In his book, Thinking Fast and Slow, Kahneman argues that our brains use shortcuts and substitution structures to try and solve complex problems with less time or energy. In other words, our brains try to be lazy whenever possible. If I ask you to solve the problem 2 times 2, you will solve that quickly because you memorized that one in grade school. But if I ask you to multiply 4 times 20, you'll use some of the shortcuts you learned in school. You can multiply 4 times 2 and then just put 0 at the end. There are shortcuts available for solving simple multiplication. But what about 7 times 13? There are no shortcuts available for this one. And doing this in your head is going to require memory. You'll have to multiply 7 times 3, which is 21, so 1 will be a digit of your product, but 2 has to be added to the product of 7 times 1, which is now 9, which gets added to the, what was the first number? Oh yeah, 1, so it's 91. Wait, does that sound right? And as you do this, you can feel your brain looking for a shortcut. It's like we have a 14-year-old sitting between our ears yelling, "This is boring, and I'm tired of it already. Just guess and give me a donut." Some of this plays into the ways that we compute probabilities. Would you make a bet where you have a 0.01% chance of losing where you pay $1,000 and a 50% chance of winning $1? We actually don't do well with the probabilities. By probability, you should take that bet. But most of us quickly decide that losing $1,000 hurts a lot worse than winning $1 feels good. The inverse of this is also true. I have a 0.00000000292 chance of winning the Texas Powerball lottery, and about a 99.999999997% chance of losing $2. But if I feel like I have $2 I can throw away on a fat chance, I may do that. Again, I don't compute probabilities well, but I don't mind losing $2 for what seems like the chance of winning millions. Another probability error is the idea of flipping a coin. Imagine that I have flipped a coin 9 times, and every time it comes up tails. I then offer you the chance to bet against the final toss. This is very tempting to take the bet, believing that the probability it will come up heads is extremely high. In fact, the probability the coin will come up heads is 50%. It feels higher because it seems like a string of 10 tails in a row would be improbable. But there is no connection between the 10th flip and the 9th. There is a 50% chance of heads on each individual flip of the coin, regardless of what happened on the previous flips. One classic error is the assumption that if 2 variables are correlated, there is a causal relationship between them. For example, in 1952, scientists noticed that there was a correlation between ice cream sales and the incidence of polio infections. In the months when ice cream sales increased, so did polio infections. But in the months when ice cream sales were down, there were fewer infections. This caused a huge panic about ice cream. People were sure that this correlation inferred that ice cream caused polio. As it happens, there was a reason that they were correlated. It had to do with kids being involved in activities where infection spread more easily, such as swimming. A last example of cognitive error is when we accidentally pay attention to data that support a pre-existing belief and fail to take into account data that would call my belief into question. Imagine that I believe that the MMR vaccine causes autism. They don't, and the science is emphatically clear, but let's pretend I believe that they do. If I'm an anti-vaxxer, that is a person who believes that childhood vaccines are dangerous, then I might be tempted to look at one outlier piece of evidence or one scientific report and fail to see a whole universe of other data. In fact, this is precisely what happened in 1998. Dr. Andrew Wakefield published some research that appeared to support the view that there was a link between the MMR vaccine and autism spectrum disorder. As it happens, Wakefield carefully selected the children in his study so that it would appear that there was a link. The thing is, there were some people, some of whom were celebrities, who'd already believed that the MMR vaccine caused autism in their own children. So this single study, later retracted by the Lancet Journal, has given support to that idea, even as hundreds of other studies conducted ethically and with proper design demonstrate that there is no link. This is how a good conspiracy theory develops, by the way. If, for example, you believe that there is a deep state, or a trilateral commission, or that the Denver airport sits above an underground city designed to be the headquarters for the New World Order, you can find what seem to be criteria of justification for these beliefs. A person has to start with the belief, and then confirmation bias will allow him to see the evidence. Last week, we saw that we don't always have the perspective to accurately evaluate whether our beliefs are justified. This week, we've seen that our brains can trick us. Whether it's because our brains are lazy, or whether we have systems and structures in place that work in some instances while they fail in others, we cannot always trust that our brains are acting in rational ways. Sometimes, like with coin magic, our brains are tricking us. In discussion this week, you'll take some time to evaluate who gets to influence the ways that you make decisions about which criteria of justification you decide to use. For your assignment, you'll take some time to think about where some of the feelings and emotions that attach us to our beliefs come from. And if you're starting to wonder, then how can anyone believe anything at all? Well, we're going to address that next week. There are ways to put this all back together again. Have a wonderful week.